I asked it to give me a problem of this structure that was irreducible, and it finally was like, okay, here's one right here. And the answer is 2x plus 5 over x plus 2, but that's actually incorrect. But somewhere in here, ChatGPT made a mistake. I want to write a problem of the form x plus c over x plus a plus x plus d over x plus b. So this would be adding rational expressions. That's the type of problem this is. And so here's where I use ChatGPT. I like to use it to help me write problems. So I'll ask it to do just that for me, write me a problem of that form. And here it goes. It gives me one. Of course, it's implied here that a, b, c, and d are all integers. It gave me 2, 3, 4, and 5. And let's go ahead and solve it and see what it does here. Okay, good. So the final answer here was factorable, but the what you'll notice here is that the problem was irreducible. And I like reducing. I like it when problems simplify. So I'm gonna set out. I guess I could just ask ChatGPT to do it, but let's do some work by hand. I'm gonna set out. I'm gonna try to write a problem of this structure, but where the final answer reduces. So I would cross multiply essentially. So I'd x plus b times x plus c plus x plus a over x plus d. And this would now all be over the least common denominator of x plus a times x plus b, right? So, but if you're familiar with these types of problems, we're really only going to work the numerator down. So I'm going to go ahead and just ignore the denominator. We're not going to need it. Let's just work this down and see what happens. So if I distribute these, I would have x squared plus b plus cx plus bc. And then over here, I would have x squared plus a plus dx plus ad. And then let's combine like terms. So this ends up with a 2x squared plus a plus b plus c plus d x plus ad plus bc, right? Okay, so this right here would be the resulting trinomial in the numerator. So if we're looking at ChatGPT, this would correspond to the 2x squared plus 14 plus 22, just the numerator. So this right here, what I have written down, corresponds to what I have highlighted. But good. So I want my final answer to be reducible, which means that when I factor the final answer, this right here, if I factor this trinomial, I want it to factor, and one of the factors either needs to be x plus a or it needs to be x plus b. If I can get one of those factors out of this, then I can cancel out in the end. So basically, I want this trinomial right here, I want this trinomial to end up being, I want it to factor to something like 2x plus m. I'm introducing a new number m here. And then let's go ahead and see if we can squeeze an x plus a out of it. So if I distribute this, what I want, that would be 2x squared plus, let's see, 2a plus mx plus a m, right? Okay. So I want this to end up being that. If I can make that happen, then my answer will be reducible. So let's match up the parts. Obviously, the 2 is going to be a 2. But we're going to get one equation here by setting a plus b plus c plus d equal to 2a plus m. So this will be our first equation. Equation 1. We want a plus b plus c plus d. We want that equal to 2a plus m. Then we'll have the second equation here where I want AD plus BC. I want that to be the same as AM. So AM equals AD plus BC. Okay, so realize here we have 5 variables but only 2 equations. Now, we can only solve for 2 variables with 2 equations. So what would happen here is I would basically pick what I want B, C, and D to be. So I would choose numbers for B, C, and D. Meaning you could put a 2, 3, 4. You could put a B equals -10, a C equals 5, and a D equals 7, right? Whatever you want. So we're going to treat B, C, D as constants, and we're going to treat A and M as the variables. Well, let's go ahead and simplify this first equation right here. I could subtract 1A from both sides. I could subtract an A from both sides, and that cancels that A out. So I have B plus C plus D equals A plus M. And then let's go ahead and solve this. How do I want to do this? Let's go ahead and solve this for A. So A equals B plus C plus D minus M. I just subtract M to the other side, and then I want to substitute this into this equation up here. So I do want to substitute this into that A. So if I make that substitution, I would have B plus C plus D minus M times M equals... Is this really the way to do this? My goodness. Do I have to substitute again? I don't like this. I don't like this. Hold up. Let me think about this for a minute here. Wouldn't really matter. You know, the move here would have been to solve this equation for M instead of A, because you notice over here we have two A's, but only one M. So that would have been the smart thing to do. So let's go ahead and switch the M and the A. There's a nice symmetry there anyways. It works itself out. So then substituting that would become A parentheses B plus C plus D minus A. Good. Okay, so we've eliminated the M. We've substituted the M out. Thus, this equation now only has one variable. Remember, we're treating B, C, and D as constants, so the only variable here is A. Let's solve for A. So if we distribute AB plus AC plus AD minus A squared, it's going to be a quadratic in A. AD plus BC, right? Okay. Good. So let's take this equation right here. Let's take this equation right here. I want to solve this. We need to solve this for A. Solve for A. Solve for A. All right. I want my quadratic term to be positive, so I'm going to go ahead and move that to the other side. That would be minus AB minus AC minus AD plus AD plus BC. I moved everything to one side, and it looks like here, that's nice, we have an AD and minus AD plus AD. Those cancel. So we're left with A squared minus B plus CA and then plus BC. So you might have to think about what I just did here, but I'm basically setting this up as an AX squared plus BX plus C because I want to apply the quadratic formula to it. So if I apply the quadratic formula, I would have, right, quad formula. Negative B plus or minus the square root of B squared minus 4AC all over 2A, which is just 2. Okay, great. So let's do the positive case first, B plus C. So we'll do the positive case first. Actually, what we should do first is just simplify the discriminant. Why don't we do that first? Let's just start with the discriminant. Discriminant. Okay, good. Now, I wasn't just going to use ChatGPT once. At this point in the problem, I know how to do the algebra. I know how to do the algebra. If you're watching this, you probably do too. So I'm going to use ChatGPT here to speed up the process. I want to simplify the discriminant, which is B plus C squared minus, 4BC. Simplify. Let's see what it does. Okay, it simplifies, the discriminant here simplifies to b squared minus 2bc plus c squared, right? And you may or may not recognize that. That is a perfect square trinomial, meaning that, come on, these free trials. All right, hold up. It's only giving me 10 minutes at a time. Let's bring it back. Full screen. There we go. Okay. Cool. So the discriminant here simplifies to, and ChatGPT did some of the heavy lifting for me, which was very nice, b squared minus 2bc plus c squared. That's a perfect square trinomial, which factors to b minus c squared. And this is amazing. Like, this should satisfy you, because this right here is underneath the square root, and we just got something squared, which means we can very cleanly take the square root of that. So the square root of this, and let's go into the positive case here. So we have b plus c plus the square root of b minus c squared. Oh, this is wild. This is pretty cool. All over 2. And then, of course, if we square root that, we have b plus c plus b minus c over 2, which is 2b over 2, which is b, right? So this is, again, what I'm trying to do is I'm trying to write the rational expression problem where the final answer simplifies, but it would only work if a equaled b. We were solving for a here. A was a quadratic. We had a quadratic in a. We solved it. We did the positive case, and it would only work if a equals b. But what about the negative case? Well, in the negative case, I'm going to skip a few steps here. You'd have b plus c minus b minus c over 2. Distribute the negative, and then you would combine like terms to get 2c over c. Okay, so the other possibility is that a would have to equal c. If I want the final answer, I know you probably even forgot what we're doing here, but the context is I'm trying to write this rational expressions problem where the final answer is reducible, and that's only possible. What is the original structure? I want this to be the structure, and this proof here is telling me that it's only possible if a equals b. In other words, if both original denominators are the same, or if a equals c, right? And if that was the case, that fraction would just cancel out. So it turns out this is impossible. Now, what I want to do is now that I know, and I'll slowly scroll through this if you want to screenshot any of that. But again, we proved that this only works if a equals b or a equals c. But now what I want to do here is I want to ask ChatGPT to write me this problem again. So write me a problem of this form and then solve. Okay, it solved it. And we, as expected, it's not reducible, right? This is the final answer. Look at that 2x squared right there. You see that 2x squared? That's always going to be there in this type of problem, right? We had that right here, 2x squared. So the first term is always going to be that. But write me the same type of problem, but make the final answer reducible. I want to see how it handles this. I already know that it's impossible. We just proved it. But you see it? Look at, there it is right there. See how you have a 4 there and a 4 there? That is our A equals C criteria. Is it? Because it would have to be on top of each other. Well, let's see here. Let's see. Solve it. But it's not, right? So it said that it satisfied what I asked for, but it doesn't, right? This answer was not reducible. Write one that is. Well, that's cool. This is a good problem because the final trinomial in the numerator was factorable. That's a great problem, actually. But it still doesn't reduce. Still doesn't reduce. Didn't go back. Didn't already do this problem. It already did this problem. Here, it's got another one. We're going. Notice that there are no further factors that can be good. This still doesn't quite meet your expectations of cancellations, so I appreciate your patience. Let's try with a clean, reducible example. Okay, keep going. It's doing this x plus a over x plus b plus x plus b over x plus a. Okay, look at that. It seems to have given me one. The final answer here, the x plus 1's cancel out. And there it is right there. Fascinating, fascinating. Okay, but watch this, watch this. This is what I'm trying to get at here. This is the original problem right here. I'm not going to solve it. Well, let me ask chat to do this. Let's see if it'll fix itself. Simplify x plus 2 divided by x plus 1 plus x plus 1, x plus 1 divided by x plus 2. Do I have that all out correctly? Yes. You see how it gave us a different answer this time? So this is the correct answer. I'm pretty sure this is the correct answer. Why don't we double check with Photomath, right? I'm using all the apps right now. Photomath I trust completely. Photomath has never given me something incorrect. And it agrees with this answer right here. Okay, good. So what's the purpose of this video? There's a lot going on right now. I was showing you how to do a proof, right? We proved that X would have to be, that A would have to be B or A would have to be C. We proved that. But also what I'm getting at here is to be careful, advise you to be careful with ChatGPT, because I asked it to give me a problem of this structure that was irreducible, and it finally was like, okay, here's one right here. And the answer is 2x plus 5 over x plus 2, but that's actually incorrect. Somewhere in this math, you can pause the video and screenshot this. I'm not going to pick it apart right now. But somewhere in here, ChatGPT made a mistake, because we proved that this is not reducible unless A equals B or A equals C. And this original problem up here does not satisfy those conditions. Neither here. We have an A equals D and a B equals C, but that is not what we came up with in our work. So the actual answer to that question is here, which is not reducible, as we showed it wouldn't be. Thank you for sticking around. Hope you learned something. Please like and subscribe, and we'll see you in the next one.